Hope everybody's doing well. This is part 2 to the Gleason's map and how it is used. I'm going to show how to get distances, and we're going to do from Sydney to Perth and from Santiago to Sydney. But real quick, I wanted to show, because there's still a couple of stubborn mules out there who think the AE map it was derived from a globe. Well, here's some of the history. It dates all the way back to the ancient Egyptians, and it dates back to the 11th century and all throughout history, because it's the true projection of the world. I personally believe that it's blatantly obvious that whoever made the globe hijacked the information from an AE map. It's the only way to map a celestial dome onto a surface. You can't map a celestial dome, which is what they use for latitudes, so you can't use a 2D surface. It's not possible. So they used the globe. It was easier, and then people, I guess, started thinking it was a globe just because of that. But that's not reality. So you look and see who all's used this map. I mean, it's used by the USGS, by all radar, by military, for missiles. All the directions are accurate. It's the logo, obviously, for the United Nations. But anyway, I mainly just wanted to show that the AE map came way before the globe. Whoever tells you different is either ignorant or lying through their teeth. In a previous video, I used the 24-hour method because there's 24 longitudes, but I'm going to do it the conventional way in this video and just use two 12-hour sections. So from the center of the map to the right edge is 0 longitude, or Greenwich meridian. It marks 0. Anything above that is east of Greenwich, and anything below it is west of Greenwich. And it goes all the way to the other side, which is 180. So you have east, you could go from 0 to 180 east of Greenwich, or 0 to 180 west of Greenwich. East being above, west being below. So the latitude lines are circles, and there are 12 main latitude lines that are 15 degrees apart. The red line is the equator. Anything above the equator goes from 0 to 90, and there are positive latitude, and below the equator, or the outside, is negative 0 to 90. And you also have the Tropic of Cancer and Capricorn. So let me show you how this works on the map. We start off right there at Greenwich, and then every line is 15, 30, 45, all the way to 180. So 0 to 180, and so that's east of Greenwich. Anything above is east of Greenwich, and anything below is west of Greenwich. It's the same thing, 0, 15, 30, so on, all the way to 180. So we'll find our city, and we'll start by measuring the longitude. It says that the degrees in longitude reduce to the sun time in minutes, and that everything reduces to 60 nautical miles per degree. And that's why there are so many little lines here on the outside, because between every longitude or every time zone there are 60 minutes of arc. So for every 15 degrees there's 60 minutes, or 4 minutes per degree of arc. So the main takeaway from this introduction is that this map reduces 60 minutes of arc to 15 degrees of longitude at 60 nautical miles per degree. So let's check distances. We're going to start with getting the latitude to Sydney, Australia. So to get the latitude of Sydney, there's 30 south, or negative 30 degrees latitude, and then there's 45. And we see Sydney's in between 30 and 45 south latitude. So in between these latitude lines, we're going to make a little mini scale with 15 individual degrees to get easy and accurate measurements. I actually meant to use the other scale, but it doesn't matter. It's the same principle here. It used to be built in as a hand on the Gleason's map, but instead of cutting it out, we're going to transfer it onto a piece of paper. So I'll show you in just a second. You see, between 30 and 45 degrees, there's 15 little lines, and there's 5 bigger lines. We'll mark between 2 latitudes, and we'll mark 5 big lines. See how it's labeled here, 3, 6, 9, 12, and 15. Then we'll fill in the tweeners, the 1, 2, the 4, 5, the 7, 8, so on. Or you could just take the piece of paper and put it over the scale and trace it. And you can hang on to it, so every time you need to get a city's latitude accurate within a degree, then you will have it. So I'm going to show you how this works. So now we're going to locate Sydney, and we're going to locate the nearest latitude line, which is 30 degrees. Then we're going to set our scale down and count the individual degrees. And we get 1, 2, 3, 4. So Sydney is 34 degrees south latitude, or negative 34 degrees south latitude. Now we're going to go and write down negative 34 degrees for Sydney's latitude, and then we're going to go on to the longitude. Now we're going to use a string line for longitude. Make sure it's long enough to make it out past the edge. Also make sure it's perfectly centered. Then you want to line it up exactly with Sydney, and you want to mark it, and it's 1 degree past the 150th east longitude. So that's 150 degrees east of Greenwich. So I circled where it's marked on the map. It's a little hard to make out here. You can count over from Greenwich if you'd like. Now we're going to record our longitude. So we have 34 south latitude and 151 east longitude. Next, we will do the same for Perth, and then we will follow Gleason's instructions and calculate the distance. So we've located Perth, and we got our little scale. We got 1530 degrees, and a little past 30. We're going to line up our little scale, and we get, let's see, 2 degrees past 30. So 32 degrees south latitude for Perth. Now for the longitude. So we pull our string, and the nearest longitude is 105 east, and then we got 110, 115, yeah, 115 east longitude. So now we could get the distance between Sydney and Perth. So it's negative 32 latitude and 115. So how many degrees are these apart? So there's Sydney, and the longitude from Sydney and the longitude from Perth. So we subtract 115 from 151, and we get 36 degrees. So 36 degrees times 60 nautical miles is 2,160 nautical miles. If we convert that into kilometers, it's approximately 4,000 kilometers. So not 5,000 miles. That's not the way the AE map works, b-ball. So now we're going to check the distance between Sydney and Santiago. And since we already got the coordinates for Sydney, we're going to do Santiago. And I've already showed y'all how to do it. So I'm just going to skip to the results. So for Chile, we have 33 south latitude. And for longitude, it's 71.5 west of Greenwich. So 71.5 west longitude. So we have 8 full longitudes. So 8 times 15 degrees is 120. And then from Santiago, we have 3.5 left over. And then for Sydney, we have 14. So altogether, that's 137.5 degrees times 60 nautical miles is 8,250 nautical miles to do flat earth circumnavigation between Sydney and Santiago. That's roughly 15,279 kilometers. So it ain't no 30,000 miles. This is how it works. This is according to Gleason's instructions. So if you believe the globe, then that flight does about between 400 and 450 miles per hour. Which I don't believe for 1 second, because they're in some of the fastest jet streams down there. So on a flat earth, they're doing about 650 miles per hour. Which one seems more realistic? I'm going with the Gleason. I will have one more part to this, but thanks for watching.